Thank you, Anthony. It has been great hearing Aldi, John, and Jay. And obviously, AI Drivers' mission is along the same line. At AI Drivers, our mission, how we can accelerate autonomous mobility to meet industry needs for resilience and safety and sustainability. And AI Drivers was initially motivated by looking at that, the current desperate needs for the port industry. Obviously, as it has been highlighted, there's a huge amount of challenge in terms of inefficiency and challenge in terms of the shortage of skilled laborers, and that introduced high operating cost. Most of these, the equipment operating a majority manually or semi-automated, and obviously there are great initiatives being made for automating these equipment. And for us, finding the innovative approach wasn't new. So we look at that, how we can do retrofitting. And obviously the port industry, the retrofitting was already in place, and they were retrofitting existing cranes and for automating them for carrying out the work. So there was the big challenge was horizontal transportation, right? And autonomous technologies been developed, has been researched intensively and looking to it, right? And however, when we look at the port industry, there was a different need because the vehicles already integral part of the port operators. They have their own fleet and the trusted suppliers or tested platforms. And for us, that deploying autonomous vehicles was looking at converting the existing fleet and how we can deploy that, and that can deliver the resilience and also the sustainability that port operators today expect. And so that's the approach that we have taken. And automation, it doesn't only means in efficiency, automation also means achieving the fixed operating cost and delivering very competitive services in the market. So at the moment, we have developed our retrofitting solution that can deploy it with almost zero downtime, because we bring all the changes on the vehicle level, and we don't bring any changes for environment. So we don't request stopping any system operations, and which port operators cannot afford stopping them. And return, how can we either immediately support them in reducing costs, remaining competitive and providing services for the supply chain, and as well as reduce, in this case, energy consumption. So the technology that we have built that is directly applicable for both brownfield and greenfield. That means it is scalable. So when we look at the landscape of horizontal transportation, obviously, traditionally we have a manual driven vehicles, and there are initiatives being made for AGVs, and everyone knows AGV requires environment preparation, in this case infrastructure upgrades, and it is on that context not scalable, and that makes technology inaccessible, obviously expensive. On the other hand, the autonomous prime movers requires no environment upgrades, which makes this platform particularly cost effective and also accessible and scalable. So in this context, we built a brain that can drive basically a vehicle on that terminal, and that particular brain can be deployed one trucks or all the trucks on that terminals. So it doesn't make no differences in terms of deployment. That's why when we look at in particular approach for this autonomous prime movers, this makes rapidly deployable, because all we bring is that changes for the vehicle, changing, basically adding EPUs and sensors, and converting existing the manual driven vehicles drivable by wire, right? And that's not just delivering efficient automation or delivering lower cost solution, but also reducing emissions by minimizing the waste in this case. Traditionally, these vehicles are driven around the clock. So if single trucks can do up to over 50,000 kilometers a year. So we can now minimize the usage of the energy, either it is, in this case, if it is a diesel, obviously that represent huge amount of emission reduction. Even in future, if you're going to go for electrics, and we're still reducing the energy consumption up to 30%, and that will give a huge contribution, not just the efficiency of the solution, but as well as the environment friendly and protection for the actual atmosphere, right? So to just give you highlights of some compilation and on the AI drivers. And yes, we started in terms of retrofitting sites, and we also work with our partners manufacturing new vehicles beyond just autonomous drive algorithms. We do have necessary tools that gives you much better visualization of the AI data or AI algorithms, in this case, building that confident understanding that how a system works, providing the actual understanding of every single module that been deployed on there. And obviously the port industry introduced very unique challenge, and by now the port operators or suppliers already know that GPS is not reliable, and in the port industry due to the noise, and the same to other sensors not reliable. So at AI Drivers, we developed the solution that goes on the vehicle that provides the autonomous driving of that particular platform, and we developed a solution that goes on the cloud, provides much better understanding of the operations with the operation cognitives, and as well as the overcoming the challenges today that we are facing in terms of scheduling the vehicle for effective job and planning the path, and as well as the self-aware operations. So this system is not just providing the efficiency of the operations, but also it provides much better self-aware operation or self-aware system that be able to understand overall operations of the port's terminal. So today, our system we deploy on the vehicles or on the cranes that makes that platform fully autonomous and provide necessary information for the port operators and being able to carrying out that task. And as well as we provide the cloud services that enhance the operation cognitives beyond just understanding of the operations, that gives you much better mobility analytics and V2X capability and digital twin. So I think one of the things that we have picked up on the early stages of looking at the safety of this platform, and we have incorporated the safety from the vehicle robotics to the level of the actual on algorithm level. Make sure the system retrofitted has a fail-safe mechanism, and as well as it gives you a self-diagnostics and prognostics capability. So as Jay was mentioning, as being able to understand the failures before it failed, right? And I believe in 5-10 years time, none of these industrial operations will fail whilst operating. We will know these things before it fails, and they will be cured. And this can also be feedback for the manufacturers in future. They can make a better systems, and these sort of the challenges that we are facing traditionally, but they will be overcome use of the intelligent algorithms to be able to predict certain challenges along the line. So we have incorporated the safety from the vehicle conversions and the controls, and as well as the sensing and high level and operation level. So as I mentioned, that one of the good thing is that when we convert these vehicles, it is not just autonomous driven, but it can be also manually driven or remotely controlled or remotely driven. So in this case, the port operators has a freedom of mixing, and between autonomous operation and manual driven. So it's based on the needs. So this gives you that level of the flexibility, and also more importantly, there's a zero changes required from the terminal environment perspectives or infrastructure perspectives. So I think important thing here is that when you convert these machines for autonomous operations, the operators would like to know that everything goes inside is basically carried out safely and carried out appropriately. So we have all the tools that understand that how the vehicles are operating, and where that, for example, if any the shortcoming or poor performance coming in, we can understand that before even happening that. So we have built not just navigation, but also other necessary utility tools that gives you that level of insight of the autonomous operations. So from fleet side, I think that one of the biggest challenge today is that effective scheduling. So at the moment, majority, the one job schedule at a time. Right now, the future is that how can you schedule multiple jobs for each vehicles, and how can you understand, how can you deliver that in-time operations, without rebuilding a new terminal, right? And also these vehicles are very intelligent, moving around. We collect data and we utilize this data back to generate other more informations beyond that. One of the most important thing which Jay touches, a digital twin. So in our case, we built our digital twin that delivers autonomous operations and the integration of autonomous operation, deployment of autonomous operations. So today we have a true digital twin like to like, so that operates on a global the map coordinates. So we can have the same algorithms that we deploy on the real track, we can deploy on this virtual track. So the same algorithm that operates in this case crane, that operates the virtual crane. So all the algorithms that we built for the real equipment, that we can connect that on a digital twin. And this means the little AI robots that can be deployed on a real equipment, that can be deployed on the virtual equipment. And you can have a full accessibility of restudying and for efficiency, and restudying for improvement, and also understanding of the actual true bottleneck, right? So just give you the actual architecture is that our digital twin remain transparent for our autonomous driving algorithms, remain transparent for a fleet system, and it remains transparent for the, in this case, TOS system that schedule the jobs. So having said that, the remote control become very much widely utilized for exceptional handling in the port operating port terminals, and now we are making this remote handling more safer, right? Safer for teleoperations, and also easier for a control in this case, right? That's from me, from Aidrivers. So beating the 10 minutes. Thank you.